Good morning, students. Today you are going to learn how to write the electronic configuration of different atoms. By now, you have learned from my previous video the maximum capacity of holding or accommodating electrons by each shell around the nucleus. And that can be calculated by the formula 2n square, where n is equal to number of shell. According to this formula, the first shell around the nucleus, that is K shell, can accommodate maximum 2 electrons in it. The second shell, that is L shell, can accommodate maximum 8 electrons in it. Third shell, that is M shell, can have maximum 18 electrons in it, whereas the fourth shell, that is N shell, can accommodate maximum 32 electrons in it. Now, before you start writing electronic configuration of different atoms, you need to remember you need to memorize the name of the elements according to their atomic number starting from 1 to 20. Now, what is atomic number? Atomic number means the total number of protons present in the nucleus of an atom of an element. Now, atomic number not only tells us about the number of protons an atom has, it also tells us about the number of electrons an atom has, because in an atom there is always equal number of protons and electrons. Okay, so now here you can see some of the example, some of the elements I have written over here of different atomic numbers. Now let's start with hydrogen, whose atomic number is 1, which means it has 1 proton as well as 1 electron in it. Okay, now this 1 electron will definitely enter the first shell, that is K shell, which has maximum capacity of holding 2 electrons. So obviously 1 electron will enter the first shell, that is K shell. And the arrangement of electrons in different shells around the nucleus is only known as electronic configuration. So the electronic configuration of hydrogen atom will be 1, which is present in the K shell. Now for helium, you can see its atomic number is 2. That means it has 2 protons as well as 2 electrons. And these 2 electrons will definitely enter the first shell again, which is K shell. And as the K shell can accommodate maximum 2 electrons. Okay. Now for carbon, here you can see that it has 6 electrons in it. So out of 6 electrons, first 2 electrons will definitely enter the first shell, that is K shell. Now carbon is left with 4 more electrons, right? Because 2 has already gone to the first shell. So now it is left with 4 more electrons, which will definitely enter the next shell, that is L shell, because K shell cannot have more than 2 electrons. Okay, so the electronic configuration of carbon will be 2 and 4, which are present in K and L shell respectively. For fluorine, you can see its atomic number is 9, therefore it has 9 protons as well as 9 electrons. So out of 9 electrons, first 2 will definitely enter the first shell, that is K shell. Now it is left with 7 more electrons, which are definitely going to the next shell, that is L shell. Now remember, L shell can accommodate maximum 8 electrons. So now let's see what happens to the next element. Next element is neon, which has 10 electrons. So out of 10, 2 again will enter the first shell, that is K shell. And now neon is left with 8 more electrons, which will definitely move to the second shell, that is L shell. For magnesium, it has 12 electrons because its atomic number is 12. So out of 12, first will again enter the first shell, K shell. Now it is left with 10 more electrons. So out of 10, obviously 8 electrons will enter the L shell. Not more than 8, because L shell maximum capacity is 8. So it can accommodate maximum 8 electrons only. So now after having 8 electrons, okay, so magnesium is left with, means after entering 8 electrons in the L shell, magnesium is left with 2 more electrons. So obviously those 2 electrons will enter the next shell, that is third shell or M shell. So the electronic configuration of magnesium will be 2, 8, 2. For phosphorus, you can see it has 15 electrons. Out of 15, first will enter the K shell. Then 8 electrons will enter the L shell. So after entering 8 electrons in the L shell, now 8 plus 2, 10 electrons are already filled. Okay, so how many electrons are left with phosphorus? 5 more electrons, which will definitely enter the third shell, that is M shell. For chlorine, you can see it has total 17 electrons. 2 will again enter the K shell, 8 will enter the L shell. So total now 10 electrons are already filled again. So chlorine is now left with 7 more electrons, which will definitely move to the third shell, that is M shell. For argon, you can see first 2 will again enter K shell, 8 will enter second shell. So 8 plus 2, 10 filled. Now argon is left with 8 more electrons, and these rest 8 electrons will enter the third shell, that is M shell. Now for potassium and calcium, you can see some exceptional case. That is, for potassium you can see 19 electrons it has. Out of 19, first 2 electrons will definitely enter the first shell, K shell. Again, as usual, 8 electrons will enter the second shell, that is L shell. Now after entering 8 electrons in the L shell, so 10 electrons are filled already. Okay, now how many electrons are left with potassium? 9 electrons. Okay, so these 9 electrons can enter the third shell, right? That is the M shell, but it will not happen. So you can ask why it will not happen, because M shell can accommodate maximum 18 electrons in it. So obviously 9 electrons can easily accommodate, it can easily accommodate. But the question is, according to the second rule of Bohr-Bury, you know very well that in any case of atom, the last shell, okay, the last shell of a particular atom cannot accommodate more than 8 electrons at a time, no matter whatever be the shell, M, N, whatever be the shell. If that is the last shell, if you put 9 electrons here in the M shell, then M shell will have 9 electrons, right? And in that case, M shell will be the last shell for potassium. So last shell cannot have more than 8 electrons. This is according to Bohr-Bury's second rule. So obviously, since M shell cannot have 9 electrons at a time, that's why it will be distributed this way. 8 electrons will stay in the third shell, that is M shell, and 1 electron is left, that will go to the next shell, that is N shell. For calcium also, you can see it has total 20 electrons, out of which 2 will move to the K shell, 8 will obviously enter the second shell, L shell. Now it is left with 10 electrons, so you can say 10 electrons can stay here in M shell, but no, according to Bohr-Bury's second rule, you know that it cannot accommodate more than 8 electrons at a time. Though its maximum capacity is 18, but at a time it can hold maximum 8 electrons only. So 10 electrons will be distributed this way, 8 plus 2. So 8 electrons will enter M shell, and rest 2 electrons will enter the fourth shell, that is N shell. So the electronic configuration of potassium and calcium would be 2881 and 2882 respectively. So this is how you are going to write the electronic configuration of different atoms. I hope you understood how to write the electronic configuration.